We're looking at a spinner that has 4 possible outcomes: blue, green, red, or orange. We're going to assume it's a fair spinner, and we're going to assume that it is what it looks like, that each color takes up 1/4 of the spinner. So that means the probability that the spinner lands on each of the 4 colors is 1/4. So we're going to make what's called a probability tree diagram. And we start by doing one spin. And the outcomes, once again, are blue, green, red, or orange. And the probability of each outcome is 1/4. So the difference between this and the tree diagrams we made in an earlier lesson is that we write the probability on each branch of the diagram. In this case, all of the probabilities are 1/4. Now we're going to take a second spin. And of course, for the second spin, you look at each outcome from the first spin, and then there's 4 possible outcomes that can go from that outcome. So once again, notice you could go blue and follow it with another blue, or blue and then a green, or blue and an orange, and so on. And I think you can follow the diagram. And of course, each spin is 1/4 for each color. So to get the probabilities for each of the 16 possible outcomes, it's 1/4 times 1/4, or 1/16. And one other thing we can do is actually label the outcomes as shown. So each outcome is labeled with 2 capital letters. Starting at the left, the capital B followed by another B means that the first spin landed on blue and the second spin landed on blue. The next one, of course, is first spin blue, second spin green, and so on. And of course, there's 16 possible ways to spin a spinner 2 times for this spinner, and all of the 16 outcomes are shown. The probability of each outcome is 1/16. Now we have a new spinner. This spinner is half blue, 1/4 red, and 1/4 orange. So we can assume that the probability of blue is 1/2, the probability of red is 1/4, and the probability of orange is also 1/4. So now there's just 3 outcomes, but the probabilities of each outcome are not the same. So we've marked those probabilities on our tree diagram. And then after you take the first spin, there's 3 more possible outcomes as shown. And once again, blue is 1/2, and red and orange are each 1/4. And now to get the possible combinations, now notice there's only 9. It can be blue blue, blue red, blue orange, red blue, red red, red orange, orange blue, orange red, or orange orange. And we multiply the probabilities to find the probabilities of each one of those 9 outcomes. And unlike our previous example where they were all 1/16, they're not all 1/16. You can see that a blue followed by another blue is 1/4. A blue followed by a red is 1/8. A blue followed by an orange is 1/8. A red followed by a blue is 1/8. Red followed by another red is 1/16. Red followed by orange is 1/16. Orange followed by blue is 1/8. Orange followed by red 1/16. And orange followed by orange also 1/16. Once again, we can list those 9 outcomes at the bottom. And if you add all of those fractions across the bottom row, they should all add up to 16/16, or 1. Now we're going to pull marbles out of a make-believe bag of marbles. And we're going to start with an empty bag and put into that bag 3 blue marbles, 2 red marbles, and 1 green marble. And then we're going to pull out 2 marbles, one after the other, and we're going to keep the marbles that we pull out. So this probability tree diagram gets even more interesting. There's 3 blue marbles out of 6, and I choose not to write it in lowest terms. We know that 3 out of 6 is the probability of pulling out a blue marble is 1/2, but I'm going to choose to write it as 3/6. That helps us keep track of how many marbles are in the bag. And then there's 2 red marbles in that bag of 6, or 2 out of 6. Once again, that could be put in lowest terms as 1/3, but I'm going to leave it as 2/6. And for the green marbles, it's 1 out of 6, and that is in lowest terms. Now look what happens. After we pull a marble out, if we don't put it back, there's only 5 marbles left. So in our second row of probabilities, notice the bottom number is all 5. So if you pull out a blue marble, You've pulled out one of the 3. There's only 2 blue marbles left. That's 2 out of the 5 total left. If you pull a blue marble out, then there's still 2 red marbles left, but on your next pull, it's 2 out of 5 instead of 2 out of 6. Likewise, if your first pick is a blue, the green marble is still left, but now you have a slightly better probability because on your first pick, it was a 1 out of 6 chance of pulling out a green marble. Now it's a 1 out of 5 chance to pull out a green marble. And so now, once again, there are 9 possible outcomes, but actually there's only 8, because if you were to pull the green marble out on your first pick, there aren't any left on your second pick. So if you look over on the far right, it says 0 over 5. So the probability of 2 greens in a row is 0, because 0 over 5 is 0. So there's really 8 outcomes, and we multiply the probabilities, and we don't put them in lowest terms yet. You can see it's 6 out of 30 to get blue, followed by blue, 6 out of 30 to get blue, followed by red, 3 out of 30 to get blue, followed by green, and so on. And notice in our very last one, the outcome that doesn't really exist, 0 out of 30 to get a green, followed by another green. Now we can label those outcomes blue, 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 red, blue, green, red, blue, red, 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 green, green, blue, green, red, and of course the one that has a probability of 0, green, green. And finally, let's put them in lowest terms. 3 of them have a probability of 1/5. 2 of our outcomes have a probability of 1/10. 3 of our outcomes have a probability of 1/15. And of course, our 9th phantom outcome has a probability of 0. Probability tree diagrams can be helpful in looking at probability problems that involve more than one event.